Well, hello there. This is my second time recording the significant figures video. I'm going to actually go through and do all the first round over again, because the first time through I was kind of careless because I wasn't sure whether I was going to keep up with it or not. But it seems like people are liking it, so I'm going to do more, some better versions of the videos. Okay, but basically, as you're watching any of my videos, what I would say is give me any kind of feedback if there's audio or video problems, if there's some example or some technique that I use that you like, don't like, tell me so that way I can improve. I mean, just let me know how it works out. Okay, I'm gonna obviously I don't know. I guess I should probably do an introduction. This is the first vid in the series, so I'm trying to create some videos, and also I'm probably going to create some kind of text or written versions of each of the lessons taught by either the physics or our Poe teacher, Dr. Christo. Because I know a lot of people are getting confused, especially with all this crap with adding forces, like what. So hopefully I can just explain things in a way that makes a little bit more sense. Okay, first off, I'm going to go into significant figures. Okay, when it comes to addition in significant figures, the general rule is you're going to add the numbers on the left of the decimal normally. You just add them however you normally add them. And then the numbers after the decimal, you just round to whatever the least number of decimals that appears in the problem. Not sure if that makes sense. So basically, for example, say you have, here I'll use this. Say you have 4.16 plus 12. Actually, screw this. I'm going to use the text tool, which I always forget about. Okay, so say you have 4.16 plus 12.831. What is that equal to? Okay, well, whoops, crap. Alarm hooked up to my loudspeakers, so that's not good. Okay, so the first thing that we do is we add up the digits on the left of the decimal point, right? So we've got 4 plus 12. There. Now we're going to add to that the sum of what comes after the decimal. And I mean, that should make sense. You're adding what's before the decimal and what's after the decimal, so it's going to come out to the right number. And here we get 0.16 plus 0.831. See, I'm leaving out these parts, the 4 and the 12, because we just added them before. And we're just going to add it all together. We're just breaking it up into parts to make certain things easier. So the stuff on the left of the decimal you can just add, because if you're adding together, say 5.0001 and 12, well, you know that the answer is 17 point something. I mean, maybe what's after the decimal isn't clear, but in front of the decimal, to the left of the decimal, it's just normal adding. At the end of the decimal, you add them together, and in this case, what you end up with, these 4 plus 12 is obviously 16, and then this comes out to, let me make this bigger, this right here, when you add these together, it comes out to 0.991. And that's, well, obviously when you add these together you get 16.991. But if you're going to pay attention to significant figures, you're not done yet. What you're going to do is, for addition, you just look and you see, okay, which one of these numbers has, which one of these numbers has the fewest digits after the decimal point? In this case, it is this one right here, the 4.16. And you see that only has 2 digits after the decimal point, so that means that this number can only have 2 digits after the decimal point. So we're just going to get rid of this 1. We would round, and it would round down to 16.99. That's our final answer. So we end up with this 16.99 as our final answer. see, one thing that a lot of people ask sometimes is like, why bother with significant figures? What's the point? The best reason I could say is that it helps avoid problems like, for example, I read an article the other day that said that the universe was 14.7 billion years old. Now, that article was written in 2007. But that doesn't necessarily mean that I can then go and say, okay, now the universe is 14.7 billion years old, billion and 3 years old. It just doesn't make sense to say that because I don't know with enough precision, enough accuracy to say that now it's 3 years older. Yeah, it's 3 years older, but I don't know that specifically. Hopefully that makes sense to people. Okay. Next, I'm going to go into the multiplication rules, or rather, I'm going to categorize the different kinds of numbers that appear when it comes to multiplication. So one example would be 6300, and that is something that has no decimals in it. Am I spelling that right? Yeah. I'm just going to type them in. Another example would be 0.0014, which is just a decimal. Next, an example could be 40.30, which has both numbers before and after the decimal. Then one other problem case that gives people some trouble is, say, 100 powers / multiples of 10. Mainly powers of 10. And then numbers that appear in equations. So, say we're talking about the... Actually, I'm not going to reference any equation, but say you've got 1/2 or maybe specific ratios. We'll get to that. Okay. In the case where there are no decimals, well then this is easy. You start where the decimal would be, and then you work your way to the left, and then right when you hit a non-zero number, so right when you hit this 3, well then all the rest of the numbers here are all significant digits. So in this case 6300 has 2 significant digits. So hopefully that should make sense. I mean, it's kind of like saying, okay, I know that I have 3 meters, or I know that I have 3,000 millimeters, but either way, if you have 3,000, whoops, that's a terrible 3, I'm sorry. I'll be getting a tablet soon, so the handwriting will get better. So if you have 3,000 versus 3, I mean, this obviously has one significant figure, and this, you can just ignore all those zeros, also has that one significant figure. So that's preserved. That's how you find something that's just no decimals. If it's just decimals, like this, it's also pretty easy, because basically what you do is you kind of do the opposite for the decimal point. You start on the left side, and you work your way right until, boop, there we hit a non-zero number, so now all of the rest of these are significant digits. So this one has 2 significant digits as well. So say we have, let's make this bigger. So say we have 0.000030010. Well, same process. I'm going to go from the left, work my way in. I hit a non-zero number, so now all of these are significant digits. Everything after, even this 0, it might just be a 0, but after a decimal point, zeros are important, because we know that this isn't 1, 5, it's not 1, 3, it's not 1, 2, it's 1, 0. We know that much. So all these digits are significant. So in this case, it'd be 5. Hopefully that all makes sense to everyone. If not, let me know. I'll try to explain it better. Numbers where it's before and after, these I actually think are the easiest, because, and I mean, this does not include, like, if someone puts a 0 at the beginning, because that's just stupid, so I'm not even going to include that. When there's digits before and after the decimal point, literally every single one of the numbers, oh, I almost had a perfect rectangle there, all of the numbers are significant digits, so in this case, 4. So it can be 5.126, okay, 4 significant digits, 5.12, 3 significant digits. Whenever you have something before and after the decimal point, all of them are significant digits. Powers of 10, this tends to confuse some people. It can be annoying on tests, because technically you should treat that as one significant digit, meaning you'll get an answer like 4. But that's not what the teachers want. What I would say to do is treat this like it has 3 significant digits, just to be on the safe side, because then you get the right amount of accuracy. Or like, if it, say it was 1,000, then what you want to do is treat it as 4 significant digits. It'll just make your answer a bit more reasonable, and that way you shouldn't get points taken off. For numbers and equations, and ratios and things like that, for instance, the average of 2 numbers is you add them together and you divide by 2, right? Okay, well, dividing by 2, that 2 has sort of an infinite number of significant digits, because there is no human error. We're not measuring anything to get that 2. We get it from mathematical formulas and equations. So you know for a fact that it is exactly 2. You don't have to worry about significant figures for those numbers. You can just divide by 2, and that's that. And you'll see that in a lot of different equations. Okay, so now we know how to determine how many significant figures are in a number. How do we do a multiplication of the numbers? Well, it's actually quite simple. So basically all you do is you multiply them together. So say 5.12 times 6.3457. And let's take out our handy-dandy calculator. 5.12 times 3. Oh, nope. I got that wrong. 6.3457 equals, here we have 32.489984. See, that's a lot of digits. You don't want all those digits. So what is that? Let's see, 34.4899 and something else. But see, we don't want all these digits, because we don't know that much. We don't have that much information. We're not sure it's that close. So what we do is we look, okay, this one we can see, okay, so it's got before and after, so all of these are significant digits. This one, all of them are significant digits. This one has 5. This one has 3. So since this one has the least, this is going to be like our key number. So that means that this final answer in multiplication and division can only have 3 significant digits. So 1, and it starts from the left, so starting from the left, 1, 2, 3, and then we have to round this one. So this time it rounds up. That's a terrible arrow. There we go. It rounds up, this becomes 5, and all of these just disappear. So our final answer is 34 big 0.5. That is how you do multiplication with significant figures. One rule of thumb I'd say that you can generally do to make sure that you get the right answer for significant figures is however many significant figures you're given in the problem, just use 2 more than that. So say for example in the problem you have 4 significant figures, use 6 significant figures during all the steps while you're solving it, and then just round at the very end, so that way you don't lose any accuracy. That should help. I'm running out of time, but I'll see you in the next video where I'm going to be tackling some of the basic definitions of displacement, velocity, and acceleration. See you then.